Okay, so again, we're talking about our special segments in a triangle. So tonight we are going to do altitudes of a triangle. When you think of an altitude, you should be thinking of height. You should be thinking of perpendicular. Okay, so we're looking for the segments that are perpendicular. I'm going to draw an isosceles here. And by definition of altitude, it is the segment drawn from a vertex and is perpendicular to the line containing the opposite side. Okay, so altitude definitely means perpendicular. So from a vertex, so we have 3 vertices, so you're probably going to have 3 altitudes. So from the vertex, perpendicular to the opposite side. So this is my opposite side, and I need to be perpendicular to it, which means I have to create a right angle with this. So I'm going to use like a little sticky note to show what I'm talking about. So if I go from this vertex, don't draw this in, okay? Don't draw this in. I'm just trying to prove a point. So if I go to the vertex to a point on the opposite side, yeah, I have a point here, but this has to be creating a right angle, and it definitely does not. So where can I go through my vertex and create a right angle with my side? So see, I have a right angle, which is with my sticky note. There's my right angle. Okay, so you need to create a corner or a 90-degree angle with that. So that first one that I did was definitely a wrong one. Let's look at the other one. So I'm trying to create, from this vertex, I'm trying to create a perpendicular to the line containing the opposite side. So again, I have my vertex. I'm lining up my vertex with the corner. So that would be that right angle. I'm going to do the other one and try to do a different color. So I have to go from this vertex now and go perpendicular to this opposite side. Again, I'm going to cheat a little bit by using a sticky note with a corner on it. Okay, so if I walk from here to here, I'm going to be walking perpendicular to this other side. And we can communicate with each other that it's perpendicular by putting that right angle indicator. Where the 3 altitudes intersect is called the orthocenter. More of a tidbit. Orthocenter. So if you are drawing 3 medians and they aren't intersecting, or excuse me, if you're drawing 3 altitudes and they are not intersecting, then something is definitely wrong. And I'm going to rewrite this word just so you can see what it says. I didn't write it very well. Orthocenter. Okay, so this would be an acute triangle because all the 3 angles are less than 90 degrees. So if you have an acute triangle, the intersection of the altitudes, intersection is inside the triangle. So if you have an acute triangle, the intersection is inside the triangle. Okay, here's a triangle, here's the inside. If you have a right triangle, so here's my right angle, so this is a right triangle. If I go from this vertex and walk perpendicular to the opposite side, there's my vertex, there's my right angle, I'm lining it up with my opposite side. Okay, so there's my right angle. If I do the same thing from this vertex to this opposite side, there's already a right angle there. If I go from this vertex, I'm going to turn my paper a little bit. I go from this vertex perpendicular to the opposite side. Again, there's already a right angle there. So in a right triangle, the intersection or the orthocenter is on the triangle. On the acutes, it is inside the triangle. So we have an acute, we have a right. Last one we're going to do is an obtuse. This is the one that people probably screw up the most. Okay, so I definitely have an obtuse. I have an angle that is greater than 90 degrees. This one usually isn't too bad. Okay, so I'm going to line this up, my little sticky note, and eventually you won't have to use the sticky note, hopefully. I'm going to follow that. So from this vertex to go perpendicular to the other side, I would have that altitude. Now, if I want to go from this vertex perpendicular to the opposite side, well, you can see that if I want to be perpendicular, I'm not even on the side. That's why in the definition it says to the line containing the opposite side. So not necessarily the opposite side, but the line containing. So I am going to, because it's not part of my triangle, I'm actually just going to dash it out there because it does exist. Lines don't stop. Now I'm going to line it up and create my right angle. So notice this altitude is already outside the triangle. I'm going to do the same thing to this one. So I'm going from this vertex, and I need to go to the line containing that side. I'm going to extend this out. And I'm going to dash it because it's not part of the triangle. Oopsie. And I'm going to do my sticky note again. Make sure I have a right angle. And there's that altitude. So this is an altitude. This is the altitude. And this is the altitude. If I were to extend all of these out, my orthocenter would be clear down there. So, adding to our notes, in an obtuse triangle, the intersection or the orthocenter is outside the triangle. And also on an obtuse, now I want to make a special note, you will need to expand, if you want to think of it as continue, the sides. So when I'm talking about that, I'm talking about how we had to extend our side out and extend this side out so that we actually could make the perpendicular.